So today we are going to learn more about related rates. Let's read this problem. Water runs out of a conical tank at the constant rate of 2 cubic feet per minute. The radius at the top of the tank is 5 feet and the height is 10 feet. How fast is the water level sinking when the water is 4 feet deep? Okay, so what do you have? The first thing that you realize is we have a cone. Okay, so let's try to draw a cone. So you have this cone. What information do you have? The first information that they give you is this rate. Okay, please note that this rate is going to be negative because you have this tank. Okay, and water is running out. Okay, so that's for that. The radius at the top of the tank is 5 feet. Okay, so you know that this guy is 5 feet and the height is 10. Okay, so you have that this is 10. What else do you have? How fast is the water level sinking? Okay, so you know that it should be negative. Okay, when the water is 4 feet. Okay, so what do you have? Given, okay, that dV dt is equal to -1 feet cubed per minute. Okay, you want to find, okay, and the height is basically here, so it's dH dt. Okay, when the height is 4 feet. Okay, so that's what we have, and we want this. Okay, so what else do you know? You know that the volume, okay, for a cone is going to be, volume is going to be 1/3, and it's going to be pi r squared h. Okay, and you're like, okay, we could take the derivative of that one, but it's going to be a product, and that's not pretty because you see a relationship between the radius and the height. Okay, if you remember from geometry, I know that 5/10 is going to be proportion that it's the same as r/h, because 5 is the radius and 10 is the height. Okay, so you know that this proportion is true. Moreover, you know that r is going to be equal to 5 divided by 10 times h, and this one is going to be the same as h divided by 2. Okay, so after that you were like, oh, okay, so r is equal to h/2. Indeed. Okay, so you can go ahead and plug your r, new r, that it's h divided by 2 squared times h. Okay, clean it up. Okay, so let's clean it up a little bit. So when we clean it up, we have that it's pi, okay, and you have h cubed, and then you have divided by 12. Okay, so summarizing, this is what I have so far. But volume is going to be equal to pi h cubed divided by 12. Okay, now what are you going to do? Take the derivative, okay, with respect to time. Okay, so dV dt is going to be equal to 3 pi h squared divided by 12 dH dt. Okay, are we okay with that? So now, what do you want? I want dH dt, which is this one. I do have, now I can plug stuff. Okay, so I know that dV dt is -2. Okay, then this one I can simplify it. Okay, so you can just put 4 there. Okay, so can just put pi, and then this one is going to be, what was it, 4 squared divided by 4 dH dt. Okay, you can cancel this 4's, okay, and you can tell me, okay, so I know that dH dt is equal to -2, and the 2 divide, so it's -1 divided by 2 pi, and this is going to be in which units? Feet over minute. And that's pretty much it. So for this problem that we have that a man 6 feet tall walks at a rate of 5 feet per second toward a light pole that is 16 feet tall. For A, they are asking you at what rate is the tip of his shadow moving when he's 10 feet from the base of the light. So what you have here is, this is the pole, okay? So basically this is my guy, okay? Okay, that's your guy over there. So a few things that you need to see. Okay, so they give you something. Okay, rate. Okay, so this is a rate, and then you have this one. Okay, so I'm going to call, let's call this distance. Okay, x, and this is going to be the shadow. Okay, and this is going to be your shadow. Okay, so the shadow is going to be somewhere here. Okay, that's going to be the shadow. Okay, and then I'm going to call this one, let's call it, I don't know, W. Okay, okay, so let's call that one W. Good? Okay, so what do you know? He walks at a rate of 5 feet per second. Okay, so given dx dt equals, and I would say that it's negative because the guy is walking to the left. Okay, so you know that it's feet per second. Okay, you want to find, what do you want to find? According to this, we want to find the tip of the shadow. Okay, so we want to find in this situation dw dt. Okay, when the base of the light he is x equals 10 feet. Okay, so that's what we want to find for A. Now, what are you going to do? Okay, this one is going to be quite interesting. Why? Because you need to realize that we have similar triangles. Where? Let me get my ruler. So you do have a triangle here. Okay, look at that triangle. Okay, so you have a small triangle here which is similar to this big triangle here, so we need to use that similarity, okay, to get some kind of equation. Okay, so from similarity, what do you have in this equation? From similarity, we have that W minus x divided by 6 is going to be equal to W divided by 16. Okay, are we okay with that? So you have that this is proportional, well, not proportional, it's similar to this, and then this is similar to this part. Okay, so that's basically the ratio that we have over there. After that, what we need to do is we need to solve for y. Okay, so we play with this. Okay, let me write it here. So you have that it's going to be 16w minus 16x is going to be equal to 6w, and then you have that it's going to be 10w is going to be equal to 16x. Therefore, w is going to be equal to 16 over 10, aka 8 over 5x. Okay, and then what you're going to do is, well, that's my equation, so let's take the derivative of that one. So you have dw dt is going to be equal to 8 over 5 dx dt. Okay, and now you ask yourself, what information do I have from the beginning? From the beginning, you have this one. Okay, so we just plug it in. Okay, so you can see that this is just, we cancel the 5s, and you know that this is negative 8 feet per second. Okay, and that's pretty much for A. So for part B, what we have is that at what rate is the length of his shadow moving when he is 10 feet from the base of the light? Okay, so what do you have here? Okay, basically what they are asking for is you have B. Okay, you have a lot of information given, and you have the dx dt that you have here at the beginning. Okay, is equal to 5, and also now that you have this piece of information, you have that dw dt is equal to negative, and this was negative. Okay, and this is negative 8. Okay, so when specifically when, and it's this one. Okay, so x equals 10 again. Okay, feet. So what are you going to do here? what you have here is they are asking for this area. That area, you know that it's going to be w minus x. Moreover, they are asking for the derivative with respect to time of that one. Okay, so what are you going to do? You just take the derivative implicitly. Okay, so what's the derivative of w? It's just dw dt minus dx dt. So do you have all the information needed? Absolutely. I know that the first one is -8 and the second one is -5. So you know that this rate, okay, is going to be -3 feet per second, and that's pretty much it. Okay, so think simple and then you'll be okay with related rates.